Have you ever wondered how your phone always seems to know exactly where you are? Whether you're in a new city looking for directions or simply checking a location on an app, GPS can find you within seconds. But how is that possible? There are no rulers in the sky, and no one is measuring distances by hand. Yet somehow your phone can determine its position with an incredibly accuracy. The answer lies in mathematics, more specifically in a theorem discovered over 2,000 years ago by Pythagoras. In this video, I will show you how an ancient mathematical idea helps us understand one of the most important technologies we use every day, GPS. To help us understand this connection, I have invited a very special guest. Hello everyone! Yes, I'm Pythagoras. Today, I will explain how the Pythagorean theorem works, how it is used in everyday life, and how it helps us understand modern technology such as GPS. The Pythagorean theorem describes the relationship between the sides of a right triangle. The formula is a squared plus b squared equals c squared. In this equation, a and b are the shorter sides of the triangle and c is the longest side, called a hypotenuse. But this theorem is more than just a formula. It helps us calculate distances that are difficult to measure directly. For example, imagine a ladder leaning against the wall. If we know the length of the ladder and the distance from the wall, we can calculate how high the ladder reaches. This idea is also used in construction, engineering, architecture, and navigation. See, my theorem is useful. Well, you might be wondering, is the Pythagorean theorem only limited to triangles? Well, actually, there are more methods and proofs that the Pythagorean theorem isn't only based on triangles, but it's also based with squares. How can we easily prove this? Well, let me show you. If we take a square with side 3, its area would be 9. And if we take another square with side 4, its area would be 16. If we position those two squares to make it like side A and side B, we could easily find that side C is 5 because 16 plus 9 equals 25. Now for my next part, I would like to present to you my model that I made with Pythagoras. He made this one a little too small, but we can fix it. This model will present my theorem in a really basic and simple way, so pay attention. Now, let's connect this idea with technology. How does GPS know where we are? To answer this question, I created a simple model. This satellite represents a GPS satellite in space. This phone represents a user on Earth. When the satellite sends a signal to the phone, it creates an invisible triangle. The height of the satellite forms one side of the triangle, and the distance along the ground forms another side. The signal traveling directly from the satellite to the phone forms the hypotenuse. Using the Pythagorean theorem, we can calculate unknown distances and better understand how location can be determined. Of course, real GPS are more advanced and use multiple satellites, but this simple model helps us understand the basic mathematical behind distance calculations. And like Connie explained, that is ancient math in modern technology. At first glance, my model may look like a simple triangle, but this simple triangle helps explain technology used by millions and billions of people every day. Without mathematical relationships, GPS would not have been able to calculate locations accurately. This shows us that mathematics is not only something we learn at school, it is a tool that helps us solve real-world problems. Today, we not only learned how GPS uses math, but we learned that the Pythagorean theorem describes the relationship between the sides of a right triangle, helps us calculate unknown distances, and allows us to better understand our own technology such as GPS and our phones. Besides technology, overall, understanding the Pythagorean theorem is a great foundation for learning trigonometry, the distance formula, and more. This theorem may have been discovered in ancient Greece, but its impact is still present in the technology we use every day. And with Pythagoras we say, ancient mathematics still guides modern technology. And thank you for listening to this presentation about the Pythagorean theory. Before I finish off, I would like to express my gratitude for this opportunity. It is an honor to represent Ecuador, especially in its first year that our country is participating in this event. I would like to thank WMI and APOL for making experiences like this possible and for encouraging students to explore, learn, share their ideas, be creative with other countries around the world. This experience has been both inspiring and meaningful, and I am truly grateful to be part of it. See you in Japan. Thank you.